Hi everyone. In this video, let's understand how a typical day goes in the life of Amazon EKS cluster. Let's say you have deployed an Amazon EKS cluster in the cloud. Now, what are the various operations that we perform on this cluster? So, there are different teams. The teams could be from security and compliance team, or the team could be from networking team, or you have a DevOps team in your company. Then you have a cluster design team, which is a set of developers who deploy their microservices in the cluster. Then there is a separate SRE team who is monitoring the cluster operations and health of the cluster. Now, how all of these teams work together and work on the cluster on a day-to-day basis and does various operations. Each team owns a separate responsibility and they track various aspects of the cluster. So let us go into the details of each of this area and each persona affects the cluster operations. Okay, so let us take a typical timeline. Before creating the cluster, we need to get into the preparation mode. The preparation mode typically includes the networking design. From networking design point of view, we have to think in terms of network topology. That means, is the cluster is connected to other clusters, or is the cluster is connected to other clouds, or is the cluster is connected to some on-prem applications? And what is the VPC shader blocks and what are the sizes? And do we have any limitations in terms of the shader block range that we can leverage? Because in a large organization, applications spread across on-prem and the cloud or different clouds as well. In that case, we may not have enough IPs from RFC 1918 series. So in that case, how do we allocate the IPs for the nodes and the pods without getting into IP exhaustion issues? So that is a very critical decision criteria with respect to networking aspect in terms of the subnets, the VPCs, header blocks, sizes, IPs, and interconnectivity between the applications across the clusters and on-prem. Then once we create the VPC and decided on the sizes and the subnets, then we create the EKS cluster. When we create the cluster, we also need to think in terms of how many node groups and what are the sizes and what is the application size as well. Do we right size the application? What is the CPU memory for each container? Are the containers are scaled properly? And if so, on what metric? Is my application is a batch processing application or a load balancer based application? Once you deploy the application, we also need to think in terms of scaling. What is the right metric? How much of buffer capacity we need to keep in mind in terms of scaling? So scaling of the containers you can do either through horizontal per autoscaler or you can do vertical per autoscaler. Each of this method varies and we need to decide based upon the application nature. And once the containers are right sized and they're scaled, next we need to think in terms of designing the node scaling. For scaling the nodes, we may use Kubernetes open source components or cloud specific cluster autoscaler, which is also very important. And how many node groups? Should we go for node groupless design or node groups? And if it's a node group, then is it a self-managed node group or is it a managed node group or there's a serverless option like for Git? So all of this decision goes into cluster design aspect. Then once this is done, the developers will start deploying their applications into various namespaces. And how many namespaces and what is the resources quota and how many um, pods can run into that namespace, are there any limitations in terms of the sizes, all of that configuration goes into the cluster design. Then the security. Security spans across the lifecycle of the cluster, right from the beginning in the preparation mode as well. Because before creating the cluster, we also need to decide what is the IAM role or IAM principles that we need to create with the least privileged permissions. Apart from creating the necessary IAM roles and the users for managing the cluster operations, we also need to think in terms of creating the roles for the developers to access the cluster. And also, we need to think in terms of creating the required RBAC policies for the developers to access the respective namespaces. And apart from that, we also need to think in terms of hardening the operating systems, which is running on the node. Should we use an Amazon EKS vended optimized AMIs? For example, Amazon Linux 2 or Bottle Rocket or Windows, or we can use any third-party operating systems like Ubuntu, RHEL, and other distros. And if it is for hardening for security and compliance, then what specific benchmarks that we need to harden this OS for? Should we do the hardening ourselves or should we use AMIs from the marketplace? So all of the decision goes into security aspect. Apart from the node hardening, we also need to think in terms of managing the secrets. How do applications store their credentials to access the databases? And how do applications talk to each other in a secure manner? Could it be mutual TLS or network policies? All of that we need to keep in mind. When we operate on the cluster, this is where the DevOps team comes into picture. The DevOps team typically creates the cluster and does also the upgrades in the cluster. The upgrade on clusters is very periodic in nature because every few months a minor Kubernetes version is released. So that means the entire cluster needs to be upgraded to that version. The upgrade involves upgrading the control plane, data plane, and any Kubernetes core components and also other third-party add-ons and controllers. All the four needs to be updated in a particular sequence to avoid any issues. The DevOps team also decide on the pipeline, the CI/CD pipeline. For CI/CD, where the container images are built, we need to decide should we use a particular cloud-specific tool chain or open source tool chain. So you can decide to use either Jenkins or the code pipeline tools or any other third-party tools for CI. And for CD also, should we go for GitOps based model or any third-party model or a typical kubectl based deployment model? All of that goes into the DevOps design. At the same time, for deploying the application, there are two different options. You can use the rolling update, which is what Kubernetes provides by default for updating your applications on a regular basis. Or you can also go for blue-green or canary, which is not supported natively in Kubernetes, but there are a lot of tools and solutions out there in the ecosystem to provide the blue-green and canary deployment model for your application. This is very subjective decision based upon the microservice requirement in terms of availability and the responsiveness. So apart from that, then we have another persona which is monitoring the cluster health and operations. So this is where the observability design comes into picture. So in this case, the team is responsible for creating the dashboards to look at the health of the cluster, the nodes, the services, parts, and everything. And they track key metrics for the health of the cluster, for the data plane and the control. This team is also responsible to monitor all the SLAs, for example, the RPO and RTO and the disaster recovery design aspects. Here, the team needs to make a decision with respect to the right tooling for observability stack. Any observability requirement spans across three areas. One is logging, the application logs, and the metrics, and also the tracing. And any good solution should encompass all these three aspects for the applications. You can use either the cloud specific toolchain, for example, CloudWatch service in AWS, or you can use open source components for observability aspects. So, for example, for monitoring the metrics, you can use Prometheus and Grafana, which is open source, and there are managed offerings as well from AWS. Or you can use CloudWatch, which is set of services which provides the logging metrics and tracing. And the final step is basically to destroy. Typically, when you have multiple clusters or transient clusters for dev and test for various staging operations, you'll be able to create and delete, update the clusters very frequently. So this is where the DevOps team provides certain tooling. They will decide on the infrastructure as a code. It could be Terraform, CloudFormation, CDK, or any other cross-plane kind of coding. So this is the decision which DevOps team takes in terms of managing the infrastructure. Now let us look at the summary for the day in the life of Amazon EKS cluster. Right. So let's first understand different roles and different persona and their responsibilities. That's very important because every team needs to take the accountability for a certain aspect of the operation of the cluster. So it's important that we assign the right set of activities to the right team and the right persona. Otherwise, Kubernetes is such a very complex technology, and one team will not be able to manage every aspect of the cluster. So it's good that every team owns a piece of that operations. And in that process, the team has to be the single point of contact for that focus area. What I mean by that is because when you make certain decisions with respect to selecting a particular options, methods, for that area, for example, if you take uh, networking design, there are different options, even in Amazon EKS VPC CNI. You can use custom networking, you can use alternate header block, and many other modes. Then why a certain option is selected and for what purpose and what's the justification. So all that needs to be clearly documented so that the next set of members joining the team will be able to run from there. And each team also should maintain a run book for various operations. For example, a typical use case is a DevOps team. When they do the cluster upgrade, they need to create a runbook in terms of what the sequence of operations that they need to do, which they component they need to upgrade first, and in what order, and any API degradation they need to keep in mind. So all of that checks they need to keep as a part of the runbooks. And the final one is basically the team needs to frequently update the functionality. As Kubernetes rolls out new features, deprecates old APIs in the newer version of the Kubernetes, then the team needs to keep a watch on these features and ensure that the latest functionality is embedded into that area for security and compliance. With this, we conclude a summary in the day of the life of Amazon EKS cluster.